Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about asymptotic analysis. Before we understand asymptotic analysis, let's understand the meaning of asymptotic word. So asymptotic is a mathematical word and the meaning of asymptotic means approaching a value. As we are analyzing algorithm programs, we here talk about our functions, and in functions we specifically talk about the input of our functions. And input of our functions is approaching a value, and that value is infinite. It means we have a function and the input to our function is going to be infinite. Means we are talking about a large input only. Next comes up asymptotic behavior. So in asymptotic analysis, we generally talk about the asymptotic behavior of a function. Now what is asymptotic behavior of a function? The asymptotic behavior of a function means when input approaches to infinity, how our function is going to behave. Right? So our input size increases up to infinity. So when input reaches to infinity, we want to know the behavior of our function, that how our function behaves. So this is all about asymptotic and asymptotic behavior. Now let's move on to asymptotic analysis. So in this analysis, we actually measure the order of growth. And how to measure the order of growth, I have shown in the previous video. If you have not watched the previous video, then I highly recommend to watch the previous video and come back here and then continue watching this video. So asymptotic analysis is the only analysis we usually use. Why? Because there are many factors affecting the performance of the applications. So that's why we use the mathematical model to analyze the algorithms. I have discussed everything about it in the previous video though. So I highly recommend to watch the previous video and then come back to this video. The cool thing about the asymptotic analysis is it does not depend upon the machine or the programming language. Right? So we do not need to care about on which machine program is running and on which programming language this program is written. And one more thing about the asymptotic analysis that we do not need to write the actual code to analyze the program. We can just write the idea of the program, we can just write the pseudocode of a program, and we can simply analyze that which algorithm is faster and which is slower. So let's take the same examples from our previous video and see how it's going to work. So in previous video we have discussed that we have two programs, function 1 and function 2. Both are trying to solve one problem, and the problem is find a square of a number. And we have calculated that function 1 takes constant amount of time and function 2 takes c2n by plus c3 amount of time. And the order of growth of function 1 is slower and the order of growth of function 2 is faster. So what we do in asymptotic analysis, first we get the expression of time taken by an algorithm. And we have taken the time taken by our function 1 is c1 and the expression of time taken by function 2 is c2n plus c3. Okay? So we can write that fn is equal to c1. Fn is nothing but the function 1. As we were running function 1 or machine 1, so we assume that the value of c1 is 10. Everything is discussed in the previous video, so I again tell you that if you have not watched the previous video, please go and check the video to understand this video properly. Okay, so on function 2 we can write gn is equal to c2n plus c3. Gn is nothing but the function 2 only. We ran this function on a faster machine, so the value of c1, value of c2 and c3 is going to be 1. It means it takes 1 unit of time to execute. Now if we say that gn is growing faster than fn, and in previous video we have proved this, that g1 is growing faster than fn, then we can say that fn divided by gn is equal to 0 when n tends to infinity. And it is only possible when n is greater than 0 and fn and gn is greater than 0 also. Fn and gn is nothing but the time taken by two function. So let's put the values. Fn by gn is equal to 0. Let's put the value of fn is c1 and value of fn is c2n by c3. c2n plus c3. Let's divide numerator and denominator by n. We get this expression. After putting the value of c1 and c2, we get this expression. When we say that n is tends to infinity and when we divide the 10 by infinity, we get 0. So ultimately we get the 0 equal to 0, and we proved that if gn is growing faster than fn, then this expression is true, and we have proved it mathematically also. This is what we do in asymptotic analysis. We first get the expression of the time taken by two algorithms, and then we calculate the order of growth of that function. And after calculating order of growth of that function, we analyze that which function is faster and which function is slower. Now, there is also a direct way to find order of growth. So in this method, what we do, we just ignore the lower order term and also ignore the leading term constant. So let's say fn is our function 1 and the time taken by function 1 is 10. It is a constant time. And gn is our second function and the time taken by second function is 1 into n plus n. So by following the rules, let's ignore the lower order term. So we cross the lower order term in function 1, so it becomes the constant. And if we delete and if we remove the lower order term in gn, let's cross the 1, let's cancel this 1. So we get n and it is a linear. So we can say that the order of growth of function gn is faster than function 1. Why? Because it is growing linearly and it is not even growing, it is a constant. So how do we figure out that constant is smaller than linear? So for this, there are some common order of growths available. And I have arranged all the common order of growth in ascending order. It means the order of growth of constant is smaller than log n. The order of growth of log n function is smaller than log n, so on and so forth. So this is arranged in an increasing order. So if you go to the left of this sequence, you get the lower order term. It means it grows very slowly. And if you go to the right of this sequence, you get the higher order term. The 2 to the power n is the highest order of term because it is exponentially growing. And n to the power n is also exponential growth. So constant is the smallest order of growth and n to the power n is the highest order of growth. So in this way, the asymptotic analysis helps us to figure out which algorithm is faster and efficient. I hope after watching this video, you have a clear understanding of how asymptotic analysis works. This is it for this video. Thanks for watching. See you in the next video.